Okay. So, for example, let me ask you a question. Okay, let us assume that you have never seen this circuit before and you want to find V out. Okay, so, how do we go about this systematically? What is the first thing you must do? First find if there is negative feedback. So, what will we do? You yank this up, what happens here? Goes up. If that goes up, what happens at the output of the op amp? Goes down. Right. And so, negative feedback, yes or no? Right. So, now we are in a position to basically apply within quotes the rules for analyzing op amp circuits. What is the rule? Well, there is no current being drawn into the terminals of the op amp and the potential at the two input terminals is exactly the same. So, this therefore, this potential difference must be 0. So, one must be this voltage V in, correct. If that is V in, there is no current flowing there, that current is 0, correct. So, this current is 0. So, what this voltage is V in. So, what is this current? V in by R 1. Well, that current going into the op amp is 0. So, all this current must be coming from R 2. And what is that current? V in by R 1. So, what is the voltage drop across R 2? V in by R 1 times R 2. So, what is the output voltage? The output voltage is this voltage plus that voltage, and that is basically V in plus V in times R 2 by R 1, which is basically V in times 1 plus R 2 by R 1, right. I mean, if we had never seen this circuit before, this is how we would go about evaluating the output. I mean, of course, we know how this circuit came about, that is another matter, but if we did not know and we had looked at this circuit for the very first time, this is exactly how we would go about it. Does it make sense? All right. And so, as I said, the op amp can be made to do a whole bunch of versatile things. So, this is what is called the non-inverting amplifier, and by appropriate choice of R 1 and R 2, you basically will be able to realize whatever gain you want. A special case of this is, what if we want a gain of 1? This is also called unity gain buffer. Okay. So, what is the formula for the gain? 1 plus R 2 by R 1, this must be equal to 1. So, what should we do? Okay, so there are many possibilities. You can make R2 equal to 0 or R1 as infinity or R1 as infinity or R2 equal to 0 and R1 equal to infinity, correct. So, if you, I mean, which is the easiest choice? If R2 is 0, then there is nothing to do, it's just a short circuit, so that is easy. R1 is infinity, R1 is an open circuit, that is also easy to do, right. So, so therefore, if we choose this approach, then the unity gain follower basically it looks like this. Right, the choice with R2 equal to 0 and R1 is infinite. Okay. Now, so we know we I mean so now let me now ask you now that we have seen all this, let me ask you a question. So, suppose we are given a current source, you are in the lab, I have given you a current source, some current I, and I told you I need you to produce a voltage source, I need a voltage I times R across, I mean across, I need you to produce a voltage, produce me a voltage. So, I have a current source I, need to produce a voltage I times R. What all approaches can we think of? So, what is the dumbest thing we can think of doing? Well, yeah, well, so the approach, the simplest approach is one is simply say, hey, you want a resistor, you want a voltage I times R, I give you a voltage I times R here, all right. What is the problem with this? What impedance is the current source? Yeah. So, one problem is that remember that there is nothing called an ideal current source, because the ideal current source output impedance is supposed to be, what is the output, what is the internal resistance of an ideal current source? Infinite. But you know that nothing in the world which is supposed to be infinite will be infinite. So, basically a real current source might have some, will have some R out. Okay. Now, I mean, even if you had an ideal current source, so let me modify the statement to saying I need to produce a voltage I naught R across a load resistance RL. Let us say, and this is RL is unknown, right. So, so to rephrase, we have a current source I need to produce a voltage I times R across a voltage source, across a resistor of value RL, correct. So, how will I do this? One way, if we simply use approach 1, which is to say I will pump current I through a resistance R, then the moment I connect RL, what happens to the voltage? It will reduce to I times R parallel RL, because some current is flowing through RL. Does it make sense? Okay. Now, what happens? So now, so this obviously this approach does not work. Any other suggestions? Suppose we had a variable voltage source, like the one we used earlier, right? We have a variable voltage source. You have a dabba with some knob. You can turn the knob. All right. How do you think now? What do you think we can do?
Pump the current source into resistor and then generate the voltage and then tweak the variable voltage source
Okay.
based on this.
No, based on, I mean, it will be more clear, right? Tell me exactly what you need me to do. So, okay, this is approach 2. You have a current,
Generating the
you push the voltage, okay. So, the voltage here is, what is the voltage here?
I times R.
I times R, okay. What do I do next?
We compare it with the Vout voltage.
Compare, very good. So, basically we have this variable voltage source connected, the variable voltage source is connected to RL, right? And what do we do? You keep monitoring V out and compare it with IR. So, so what do we need? What kind of instrument we need to compare these two voltages? Voltmeter. So, basically you say I am going to put a voltmeter between those two nodes, correct. So, this is V out. So, if V out minus I times R is greater than 0, correct. So, the voltmeter reads, let us say this is the positive of the voltmeter and this is negative of the voltmeter. The voltmeter V out minus I times R is less than 0. What does it mean? Means what? It means V out is too small. What must I do? Must increase V out, correct. In a similar manner, if V out minus I times R is greater than 0, what does it mean? V out is too large and I must decrease or reduce V out. Is this clear, folks? Okay. And so in other words, we must compare V out minus I times R. So, we need to generate V out minus I times R, right, and compare it with 0. So, if I have some voltage V out, and I need to generate V out minus I times R, can you suggest some way of doing it? I have a current source I can give you an R. Can we figure out some way of generating this voltage V out minus a voltage which is I times R? How will we produce I times R? you pass current through the resistor, you will get I times R. Now, we want to subtract that voltage from V out, correct. If you want to subtract voltages, what will you do? If you have two voltage sources, if you have a battery of voltage V 1 and another voltage source of V 2, if you want V 1 minus V 2, what will you do? Yeah, you keep the batteries in series with the appropriate orientation, correct. So, I have V out now, I want to generate V out minus I times R. So, what do you think we could do?
I have to take out the current from the
Okay.
then
What is take out current from the resistor? Tell me where I will connect what?
connect the resistor at V out.
Very good. Okay. So, basically what he is suggesting is connect the resistor R like this and then draw the current like this. So, what will this voltage drop be? I times R, right, and therefore, what will this voltage be? V out minus I times R. Okay. So, if V out, remember, if V out minus I R is less than 0, what must we do? This V out, remember, is coming from this variable voltage source, correct. So, if V out minus I R is less than 0, so if this node potential, if I call that node potential x, if V x is less than 0, I must increase V out. If V x is greater than 0, I must reduce V out, correct. So, in other words, this variable voltage source is controlled by which potential? It is controlled by V x, okay. And if V x goes up, V out must go down and vice versa, correct. So, what must be the gain of that is a voltage controlled voltage source. So, therefore, this must this voltage must be A times V x, right, and if that is A, what should be the sign of A now? If A is positive, then you must put minus times V x, correct. So, you are comparing V out minus I times R and tweaking V out in the right direction, and what should A be? What is the magnitude of A should be? It should be infinite, because even when you have an infinite, I mean where you have a finite output, you want the error which is V out minus I times R to be 0. So, you want to have an infinitesimally small error, V out minus I times R. So, this must be ideally infinity. So, it is a voltage controlled voltage source with an infinite gain. So, what is that block? We have already seen what that block is. So, let me, yeah, that is V x, right, and that is minus A times V x. So, what is that? What is this contraption? It is an op amp, except now that. So, basically which are the inputs to the op amp? V x and ground, because we are comparing V x with 0. So, basically we are what we will do, Vx and ground, and so this is V out, and I mean remember V out was connected to some load resistance RL. Okay. And what must be the signs on the op amp? Minus and plus, and this is R, correct. And if the op amp is ideal, what are the rules of the op amp telling us? What is this potential? The potential between those two nodes must be 0. What is this potential? This is ground. So, what must be this potential? Ground. So, because virtually shorted to ground, it is called a virtual ground, right. And so, if this is 0, what comment can you make about where all this current is flowing? What are the rules of the op amp? There is no current there, there is no current there, this voltage is 0. So, all this current I must be flowing through resistor R. So, what is the voltage across the resistor? IR. So, this voltage drop is I times R. Okay. So, this the voltage across the voltage of the output is nothing but 0 plus I times R. So, that is basically nothing but V out is I times R. Does it depend on RL? It does not, right. So, we have an output which is independent of RL if you have an op amp. All right. So, all right. So, this basically this is what is called it converts a voltage, it converts a current into a voltage. So, and the constant of proportionality between the output and the input has units of V out is I times R. So, the constant of proportionality is R, which is resistance, correct. So, this is what is called a trans resistance or a trans-impedance amplifier. Okay. I mean we derived the circuit from scratch, correct. But if you this is the again if you are looking at this circuit for the first time, first thing to do is you break the make sure that there is negative feedback, you break the loop, you yank this guy up. What happens to this voltage?